Okay, section 4.3, successive percentages. This is pure grade B. For example, a house goes up by 22% in 1 year, but in the next year it reduces in value by 13%. What's its value now? So you have one percentage happening in one time, then another percentage kicking in at another time. So this is one percentage after the other, hence successive percentages. Now I'm going to jump straight into page 50 and do question 2. I'll do about 5 of these if I've got time, and then we'll just close the video off and move on. Right, question 2. There are, you can follow it with me, there are 39,375 people at a football match. 24% of these are teenagers, so I'll put here teens, and 32% of these teenagers are under 16. Okay, got the picture? So that many people watching a game, 24% of these people are teenagers, and 32% of these teens are 16 and under. Sorry, under 16. How many teenagers under 16 are at the match? Well, I've got this many at the match, of which this many are teens, 24%, 0.24 as a multiplier. You don't have to press equals now. We don't need the answer for the number of teens because we're working at higher level, so let's get rid of that. Now, assuming we have a number there as an answer, which we don't need, we'll just come along and just press multiply by 32% who are under 16s. All these are the teens. As soon as I go 0.32, straight away I can calculate the number present who are teens and under 16. Right, you can study that in your own time. So 39735 multiplied by 0.24, multiply again by 0.32, and I now have 3051.6. well, let's round it off to 3052 teens under 16 years. Is that alright? Beautiful, isn't it? Moving on, that's question 2. Then it says question 4. Now, just put a line under that. Next bit. A questionnaire, the question 4, a questionnaire about a new speed limit is sent to 250 villagers. Sorry, 2,500 villagers. 72% of the questionnaires are returned. Okay, so obviously the other 28, they didn't bother with them. These have been returned. In other words, there's going to be real data that you can analyse. And 65% of these who are returned, I'm just setting up the question basically, 65% of these that were returned are in favour of the new speed limit changes. How many of the returned questionnaires are in favour of the new speed limit? So I have a population of 2,500, of which 72% returned the questionnaire, of which 65% were in favour of imposing a new speed limit. And that's all I've got to do. This is my successive percentage change. Alright, so here I go. 2500 multiplied by 0.72, that's the returns. Multiply again by 0.65, that's the returns who are in favour. And I have on my calculator 1,170 of the townsfolk, who are definitely village folk even, who are in fact happy to run with a new speed limit. Question 5. A new house, I'll try and make it fit here because I might do the longer questions later. Right, new house costs £95,000. That is incredibly cheap. Not London, is it? So new house costs that much to build, and it's sold for 26% more. So I'll put a little arrow there meaning an increase. So that's, they've done well there profit wise. A year later, an estate agent tells the owner that the house prices have gone down by 8%. So 8% down in the following year. Not so good. what is the house worth after the price fall? Well, we can't go from there to there directly for the simple reason we've skipped a whole year out in time. First, let's work out what the price is after the first year, and then take off the 8% for the second year. So here I go. Cost me £95,000 to build. If I'm going to go increase by 26%, I'm going to multiply by 1.26. That's the 100% plus the 26% on top. And obviously I've done really well. Now, I hold on to the house 1 year too long, and I drop by 8%. Well, if I'm dropping by 8%, I'll still retain 92% of the value after the first year, which is there. So multiply by 0.92, and let's see what the house is now worth. Punch it into the machine. 95,000 times 1.26 multiplied by 0.92 after the 0.92. I just press 0.2 and that will give us £110,000 and 124. Right, 110,124 pounds. There you go. That's a profit about 20,000. No, so look, 15,124 after 2 years. It's still very good. Now, question 5, question 7. Better turn over for question 7. We're talking about Ed now. Ed earns £9.60 per hour. Here he is. Let's put his wages down there. Good old Eddie. £9.60 per hour. On promotion, he gets a rise of 5%. Must have done a good job. Put a little arrow meaning rise. After a year in his job, Ed gets another rise of 2.5%. 2.5%. I'll probably put in just 2.5 in my calculator. How much is Ed paid per hour after the 2.5% increase? Again, we can't go from 9.60 onto that, and we're not allowed to add on 7.5% because he didn't get it in one go. He got it in 2 parts, and it would give you a different answer. So here I go. I'm earning 9.60 because my name is Ed. I'm going to get an increase of 5%, so that's 105%, 1.05, and because I'm doing really well, I'm going to get another increase of 2.5%, so 1.02. well, that's 2% added on, and the 5, as it was 2.5 originally, will give me the extra 2.5% added on. Now let's get Ed's brand new hourly rate. £9.60 multiplied by 1.05 multiplied by 1.025. That gives Ed £10.332. Now, this is England. That doesn't mean anything at all. You wouldn't call that 34p. That's too low. So we're looking at an hourly rate of £10.33p. That's Ed's money. Now, question 10 is a bit involved. It's got a yellow dangerous asterisk by it, and let's give it its own page, and hopefully that will fit on the video. Right, 10. I'll read it and write it at the same time. 52% of the adults in the town are women, so 52% women. 86% of these women have a job, so 86% got a job, and 28% of the women who have a job work full time. Get the picture? So 28% full time. I reckon, therefore, I've got 72% who may have a job who are part time. Now, because I'm crafty, I know I'm going to need that later, so I'll put it in there now. Okay, 100% represents these women here who have jobs. Alright, what percentage of the town's adults are women who work full time? Well, I've got 52%. This lot have jobs because they're women, which is 0.86, and to work full time I'm going to use the 28% figure. Now, I know it's going to shrink every time I multiply by a number less than 1, but I will get an answer that is true. So, 0.52 is 52% of the adults who are women, multiplied by 0.86 for those who have jobs, multiplied by 0.28 those who work full time. Therefore, I have an answer of 0.125216. Not very nice, is it? I therefore convert that into an understandable number. Bang, bang. 12.52. Leave that little bit alone. It's got far too far away. I've got 12.52% of the town are women who work full time. Okay, so that's that. Next one says in part B, that was A. Incidentally, this is B. Says what percentage of the town's adult population are women who work part time? I did tell you I'll be using that. So I want women, 52% of the town, who work, that's 86% of them. But these are the part-timers, multiplied by 0.72. Clearly it's going to be a bigger answer than that. So we just multiplied by 0.28 before. Let's get an answer. 0.52, that's your women, multiplied by 0.86. These are those who work, multiplied by 0.72. This is the part-time. These are the part-time workers. 0.32198. That's approximately 32.19. Oh, let's go to 2, shall we? So that will push it up to 0, and that will become a 2. Yeah, I'm going to go for 32.2% of women in the town work part-time. I've got 12.5% or so of women in the town who work full-time, and that, my friends, is the end of 4.3, and I'm really happy with that. Okay, so you go.